Okay, in the next video what we're going to look at is still modeling data using exponential logarithmic functions and logistic functions. As I said earlier in the videos, that they will first give you the model that you're supposed to use in the direction. They'll say use exponential, use logarithmic, use logistic, and then eventually they're going to wean you off that and they're going to say, take a look at your scatter plot, take a look at the data that which you have recorded on your calculator, and then choose the most appropriate model that you can. And that's what they're saying here. We can use a linear, quadratic, power, exponential, logarithmic, logistic. Those are the ones that we can use to possibly fit our data to help determine the best fit one. And the best fit is going to be determined by a couple of criteria. Number one, looking at your graph, you're going to give it your eagle eye. You're going to see whether you think that is a good fitting graph, but also rely on your correlation coefficient. The only one that doesn't give you a good correlation coefficient, because they won't even provide it, is logistic regression. So everything else is going to have a good regression correlation coefficient. So remember, the stronger the correlation, the closer you are to 1. So if we looked at just their quick examples here, you can see that the linear regression had a correlation coefficient of 0.74, 0.94, 0.94. They're kind of tie on that. But the exponential regression has the best correlation coefficient, and typically that's the one, even if you use by your own eye, that this will give you your best fit to the data. Logistic fits pretty well as well, so you got two here that could be a tie. So when you look at your exponential growth models and you compare it to your logistic models, go back to the context of the problem and see, is there any limiting factor which is going to keep this from growing infinitely large, or is there something in the problem, in the context of the problem, that tells you there's going to be a ceiling, like we can't go above this ceiling because of our limitations of the environment. So make sure that when you're looking at an exponential, you think that's a good fit. Don't forget to consider logistic regression. If you look at the same windows, you might see the exact same look, and that's really what you're doing. So what I'd encourage you to do is to increase your X scale on this, expand your window a little bit to see if it is going to flatten out and come down on a ceiling with your data and your scatter plot. So those are the words of wisdom that I can give you on these, but basically it's going to be through putting it in, getting your scatter plot, making a good decision based on both what the model looks like and plus your correlation coefficient value. So next one, we're going to look at the internet again. Use the data in the table to determine the regression equation that best relates the cumulative number of domain names that were purchased from the internet provider each month. Then predict how many domain names will be purchased during the 18th month. So we've got time in months, we got domain names in the bottom for your X and Y values. So what I've already done is I've already taken those values and I put them in the calculator into list 1 and list 2 on the stat. So I've already have those entered, and I just want to cruise back up and get to the top of the list. So the first year, 211. So data should be in there. Hopefully I've typed it in there correctly. So now what I want to do is I want to make a scatter plot. In order to make a scatter plot, we got to have a decent window. So we've got months that are going from 1 month to 16 months. So let's go from 1 to, let's go a 2-year period, 24. That's more than what this would require as far as our initial data. And then the next thing we're going to look at is the domain names. The lowest we could go is 0, and then the highest we're getting up there close to 600. So maybe I'll go to 650 just to give me a little cushion on the end of that. Oops, that's the min, so I got to clear that. I want to go from 0 to 650. So it is going to take a little bit of time to enter the data, to adjust your windows, and then to interpret your data. So on this, I'm probably going to go by, let's go by 50s. Enter. And now we can look at our scatter plots. I believe I still have that set up in the y equals. So there's our scatter plot, and it looks good. I probably have something entered in 1, so I'm going to take that off so I don't have that trying to graph off the top of it. And now I can hopefully get a look at the graph. All right, well here's our physical model, or our scatter plot for our model. It looks like we've got some decent shapes that could come into play here. If we look at the models they have there, and now it's just going to be a matter of determining which one is which. I think I can eliminate linear. I think I can eliminate quadratic. A power model looks like a power model doesn't quite fit that. Exponential growth model doesn't look right. It does appear that it could be a logarithmic model, so I might want to take a look at a logarithm model because the shape of the graph is increasing at a decreasing rate. And I don't know, a logistic model. Doesn't seem to be an exponential growth, so that means probably, well, it could possibly be one of those where we increase at a decreasing rate, but it doesn't look like a logistic either. And I don't know if the context of the problem, I think we could have an unlimited number of domain names, so logistic kind of doesn't make any sense. So let's go through and do some of our stat, calculate options here. So one of the things that we thought would be a viable option, at least I thought would be a viable option, was maybe look at a linear regression model and see how well it fits the data. So I said linear, but I meant logarithmic. So on list 1, list 2, we're going to store this in, and now this is where we can load up these y bars and make some comparisons. So this is the first one I'm going to run. I'm going to place this in y1. I'm going to run the regression, and I also want to keep track of what the correlation coefficient. So the log, or the natural log, had a regression correlation coefficient of 0.97. So natural log is 0.97. That's a pretty good fit. Let's see if there's any others in there that might be better. Going back and look at that at our scatter plot, and now we can look at the graph with that equation in there, and that looks pretty good, not bad at all. So kind of in the back of my mind, a little bit suspicious that maybe that's not a bad predictor of that. Let's see, what other kind of, just we'll do another test here to see, quadratic, quartic. Just for fun, I'm going to run a quartic regression because it has a little bit of an S shape in there. I guess I can't show you that graph, but it had a little bit of an S shape in that graph, so I'm going to see if I can model that S shape that cubic functions have with it. Enter. We're going to go list 1, list 2. I'm going to store that in. Now this time I'm going to choose to put that in y bars, and I'm going to go and place that in y bars number 2. Enter. Calculate. And run a regression on it. Okay, so wow, that's going to be an awfully tight. So now I need to remember what the last one was. I had to go out to the, looks like the thousandths place, because 0.97 is the same as the last one, is 0.97. So I'm going to record this one, and this one is for the cubic, so I'll just go cubic at a correlation coefficient of 0.979, if I remember that right. Okay, so then let's see if I go second, enter, second, enter, and come back and see if I can get that to the nearest under. So okay, this was 973. So our regression correlation coefficient is a little bit stronger on the cubic. Let's take a look at the graph and see if it is a better fit. Does it look like a better fit at least? And I bet we're not going to see a whole lot different, but that is kind of what I was seeing. Get this little bit of a dip. It's kind of busy right now, but our graph came up. Our dots came down and lowered just a little bit, and then it started to take off again. So that could help us figure out why this cubic model has a little bit better fit to it, because it does a little dip in there and then comes back up. So as I was trying to say, it comes up, and our scatter plot came down just a little bit, giving it just a little bit of the resemblance of an S shape, and it looks like it's on the increase once again. So between those two, the better fit is the cubic. Now you can run more regressions on other functions that you think might be better. So again, how many tests you do and what tests you do is based on what you think would be prudent. I don't think there's anything else in there that really caught my eye. Power regressions, that would mean it'd have to go through the origin. Let's see if we can do a power regression on it and see what kind of a fit we get with that. So I'm going to go and put that in the third, y equals, enter. And we're going to calculate, and we're going to see what kind of regression correlation coefficient we get with that 0.93. So that drops quite a bit, and you would be able to see in that graph, although it's going to get quite busy here with the other two. There's the cubic regression, and the last one it's graphing is a power regression. As you can see, that doesn't quite fit as well. So between the three that I've looked at so far, the cubic looks like the most promising one. So let's use the cubic. Y equals, and that means I need just the second one. So I'm going to just clean that image up. Here's our cubic regression, and now we can go ahead and answer the questions they have. I guess what the final thing was, after the 18th month, what will the sales be? Now, I think I got out there far enough on the window to cover 18 months. I got out to 24 months, so we can go back to our graph. and I want to hit a trace, and I just wanted to ask my regression equation, after the 18th month, how many domain names should there be? Based on the regression line, the estimate should be about 714 domain names. So what we're supposed to record here is the equation and also the answer is 714. So I'm going to go back to my home screen and I'm going to go second enter. I want to get the cubic regression, not the power regression. And I want to get those values off of it. And I know they're in here. There they are. So we want to record a cubic function. So we want to record, and it's just really difficult for me to go back and forth on these, so I'm going to leave it up to you. You got to put in the values for A, you got to put in the values for B, C, and D for your cubic regression, and then, as we already did, we knew there's going to be about 714 domain names in 18 months later. So there's our setup. Good luck on making the appropriate decisions on which ones you want to select as far as your regression. Look at your points and scatter plots carefully, make a wise and careful decision, and base your decision off of the fit of the graph plus your correlation coefficient, or your R values.